Welcome to qnawire.
For the gravitational force between the Earth and the satellite and its circular orbit about the Earth, we have that the force acting between the Earth and the satellite is G, capital M the mass of the Earth, little m the mass of the satellite, over the separation of the centers, r squared. And because of the circular orbit of the satellite, the force due to the centripetal force is mv squared over r. So from here, if we rearrange, we can get the speed of the satellite v to be the square root of gm over r. But we also know that v times tau is equal to 2 pi r. So tau is the period of one orbit of the satellite, and 2 pi r is the circumference or the total distance that the satellite will cover. And if we square both sides, we get that v squared tau squared is equal to gm tau squared over r, and this is equal to 4 pi squared r squared. And so we can rearrange this equation and find r. So we get r cubed, if we multiply both sides by r, is equal to gm tau squared over 4 pi squared. And so then from here we can see that the separation between the Earth and the satellite is gm tau squared over 4 pi squared to the power of 1/3. So the cube root of gm tau squared over 4 pi squared. Now that we have an expression for the separation, we can substitute our data into this equation. So tau, the period of the satellite, is 23.934 hours, and this is equal to 86.1624 times 10 to the 3 in seconds. So firstly, we are going to use SI units. In SI units, G is equal to 9.81 meters per square second. The radius of the Earth R is equal to 6.37 times 10 to the 6 meters. G times m we know is equal to the gravitational acceleration Earth little g times the square of the radius of the Earth r squared, and this is equal to 9.81 times 6.37 times 10 to the 6 squared, and this becomes 398.06 times 10 to the power 12 cubic meter per square second. So therefore, using the equation above, we can find R in SI units to be 398.06 times 10 to the 12, that's meter cube second squared, or gm, times 86.1624 times 10 to the 3 squared over 4 pi squared, and all of this to the power 1/3. And so if we perform this, we get R to be 42.145 times 10 to the 6 meters. So the separation between the satellite and the center of the Earth is 42.145 times 10 to the 6 meters. But we want to calculate the altitude. The altitude of the satellite above the Earth, we'll call it h, is equal to this distance minus the radius of the Earth. So the altitude is the height above ground, not the height above the center of the Earth. So this is, if we take this value minus big R, we get this to be 35.775 times 10 to the 6 meters. So this is actually 35,800 kilometers. So the altitude of the satellite is 35,800 kilometers. And we can redo the calculation using US customary units, where G is 32.2 feet per square second, and the radius of the Earth, big R, is 3,960 miles, which is 20,909 times 10 to the 6 feet. And if we redo the calculation, or we simply convert this answer from kilometers to miles, we get that this is 35,800 kilometers, or 22,200 miles in altitude. So for part B, we wish to calculate V in SI units and again in US units. So V is equal to the square root of GM over R. And again, we know these values. So that's the square root of 398.06 times 10 to the 12 in SI units over R, which is 42.145 times 10 to the 6 in meters. Hence, we get the speed of the satellite to be 3.07 times 10 to the 3 meters per second. And this is simply 3.07 kilometers per second. So we can do the calculation again, and we convert our units into US units, and we get the velocity to be 10.09 times 10 to the power 3 feet per second.